Hello. Okay, there we go. I don't know why it wasn't showing that. Hello, welcome to Let's Program with CNTR, and today we're going to continue working on the timeline program. Now, full disclaimer, it has been a while since I worked on this. Hopefully, what that means is that I've been able to think through things well enough to figure out how to solve the particular problem that I was running into. So, and just as a reminder of that problem, if I go ahead and get this thing started, and I'll talk through things a little bit because it'll probably take it a little bit to get this up and running. This is going to be a lesson, I hope, in one of the things to remember when you're programming, which is sometimes what you need is to take a step away. Last time, because I recorded I usually record these in big kind of sessions. So last time I was butting my head up against this problem, and I was just trying to figure out, okay, how do I fix this? How do I solve this? What do I do? And just as a reminder, if I add a couple things here, let's put this guy at 10, and let's go over here and add a thing, whatever. And I had, what did I call this? Timeline overview, all. I had this thing right here was not. I was trying to figure out how to get these things to move over appropriately, and particularly with more complicated scenarios than this one, for example. And I was really struggling with trying to figure out how to solve this problem, and I just was not coming up with a satisfactory solution. So I had this big ol' mess down here somewhere, like in this area and things, where I was just trying to figure out, okay, how do I solve this problem? And I ended up at the end of the last episode. So these are probably going to be a week apart when you see them, or maybe you're binging and you're watching them all at once. But I was just butting my head up against this problem, like, okay, how do I calculate this? How do I find this? I'm not really figuring out a good way of calculating out where to position these new split timelines, because stuff is like, calculating it all out was just being a giant nightmare. And so I took a step away because I wasn't figuring it out. And this is, like I said, the important lesson is sometimes the best way to solve a problem is to stop trying to solve the problem and just take a step away and create some space. By creating that space, creating that moment, it allowed me to have room to think and my brain to breathe. I was able to kind of ratchet down. The analogy actually that kind of came to my mind was a four-wheeling analogy, where if you're trying to like get over a rock and you're right on top of the rock, sometimes you can try really hard to get over that rock, but you just can't make it. And what you need to do is you need to back up and then start afresh. Start with a new line, a new approach, maybe give a little bit more oomph. But when you're stuck on that rock, when you're right up against it and you're stuck on it, you can't get over it because you don't have any way to kind of maneuver, right? You don't have any room or momentum or anything else. You're stuck. So you need to kind of back up and reevaluate it. And that's kind of what taking a break from a particular programming problem does. So what I've decided with the way that I'm going to approach this, and I need to refamiliarize myself with a little bit of this code because, like I said, it has been a while. But what I decided is my solution is actually up here. Is it right here? This is where I'm trying to do all my offset stuff. So if I have, I don't even know what's going on here. So what I decided, what my solution was going to be. Okay, yeah, this is, I see what's going on here. Is to man, I don't even know. This thing's a mess. What I decided my solution was going to be is, instead of whatever this gigantic pile of mess is, I'm going to just have a pointer, or a reference technically, because this is C#, and pointers exist, but they're not really used references. Basically do the same business. And what I'm going to do is I'm going to make a new timeline event node. And this one right here is going to be rightmost node. So what I decided for my solution is, instead of trying to do all of this calculation to figure out, okay, how far over does this need to be, etc., what I'm going to do is, and right here I'm going to need to do some stuff, but what I've decided I'm going to do is, let's see. I need to figure out how I want to approach this, but what I've decided to do is I'm going to just find which node is going to be the node that's going to push me over the most. Instead of trying to figure out how far over that node is ahead of time, and how far over that makes me need to be, I'm just going to kind of put it in this right here, put it in this X, so bake it into this X, and make that push it over. So I'm going to need, what did I call that? Rightmost node does not equal null. Then I just, how do I do this? I guess post equals rightmost node dot x plus root dot spacer plus timeline offset, maybe? I mean, I'm going to need to play around with it a little bit to figure out what the math actually needs to be, but it's going to be something like this. And I want to do something similar over here. So if the previous had a child... See, this is why I should have been commenting this, because now I don't remember what was going on in here. So I'm going to start doing some stuff. Get default positional offset. If we're at the same time as the previous node in a row, then go to the right of that node. Okay. I'm just kind of commenting. Otherwise, we need to see if we are being offset. So this should only get one of these if it has a child, I think, but okay, so timeline offset adjust. Okay, so if the previous child does not have a child, then we use the max of that. Okay, so what I want to do right here is, so if the previous has a child, then this needs to be moved over timeline offset. Okay, what is this value, and is it being used anywhere else? It's being used right here because I'm using it, and it's being used right here. Okay, so see, this is the problem with not commenting your code, everyone. That's why you should always comment your code. Find all references. Where is this guy being used? Right here, and right here inside this. What is this? This is get timeline width. Am I even still using this? Greatest width among lines. No, I'm not going to be using this. So that piece of information is not useful. Okay, so I'm just going to need to burn that down, and you can see also along here, the markers of where code has been changed are a lot less prevalent because this has been reopened since last time. Okay, so I don't really care about this timeline offset because I'm going to be killing it because I don't need it anymore. Yeah, I don't even know if I need any of this jazz right here. I need the timeline parent. I don't think I need those 3 things. Let's see what makes explode. So right here explodes, but I don't think I need this. This should just be that. I am going to need to do stuff with it. Get the width of the previous thing, because that's how far we'll need offset. Okay, so actually what I want to do is rather than this, I'm going to get offset position. Actually, no, I'm going to call this inline position. Find where we'd be if positioned normally, and that's going to, whoop, did I just hit insert? Oh, one moment. Okay, insert off. Nobody wants to insert on. It makes everything awful. Okay, so post is what gets returned. Cool. I need to add this to those. Okay, so then what I want to do right here is if rightmost node does not equal, wow, that's not an equal sign at all. So if we have a rightmost node, what we should be doing is we should be offsetting ourselves by the amount that we would need to for this right here, which actually needs plus rightmost node dot size dot width, I believe. So we need this calculation right here. Actually, so here's what I'm going to do. I'm going to take this and I'm going to come up here. If we have a rightmost node, base our position off of that rather than our timeline parent. Okay, so then what I want to do is, we don't need that. If we have a rightmost node, see which puts us farther to the right. Okay, so what I want right here is if posts, if that'll get fixed in a second. So check if posts the rightmost node position is further right. So if position is greater than inline position, no, actually what I want is if that is less than inline position, position equals inline position. Okay. Else position equals inline position. Okay. We don't have a rightmost node. Just use the inline. Whoop, line. Wow, I am typoing that badly. Inline position. Okay. So this, I need to rewrite this. So check if the inline position puts us further right than the position does. If so, use that instead. Okay, so here's the logic of what's going on here, just so that way I can reiterate it to myself, make sure I know what's going on. So we get the default timeline position, as we normally do. If we have a rightmost node, because this is basically like super cheap, if we have the rightmost node, our base position off of that, we base our position off of the rightmost node rather than the timeline parent. So what this is saying basically is a rightmost node is logically going to put us at a further to the right position than our timeline parent will. Because remember, our timeline parent is going to be getting offset. So if we have a rightmost node, that means that we have a timeline coming off of us. So the what we need to do at that point is say, okay, I need to be a certain amount over, so that way my children dangling off of me are not overlapping on the node that is pushing me furthest. So that's the rightmost node, right? So it's the node underneath me that is furthest to the right. So that's going to push me to the right. So I need to get that thing's information if I have it, because that's going to be pushing me further out than my timeline parent will. Now, if we are on the same line as another node, what we need to say is, well, if where we'd be positioned normally So we get where that would actually move us now. Normally, okay, so I'm gonna find where we should be positioned in this line. So what this is going to do is, because we have multiple things stacked up, right? If we have, we need to figure out where that's going to place us, because it might put us further to the right than the rightmost node forces us to be. So for example, if we have a couple of objects, a couple of events at the same time, and then a split timeline, that split timeline is probably going to be pushed out quite a ways. So we need to figure out, is that going to push us further out than the rightmost node pushes us out? And if it does, then we need to use that adjustment rather than the adjustment that the rightmost node gives us. So if we do have a rightmost node, we need to check to see, hey, is that not pushing us as far as this is pushing us? And if this is pushing us more, then we need to use that position. Now, if we don't have a rightmost node, then we just need to assign the position to the inline position that I found previously and use that, because we already know that we're in a row, we're in a line, right? So that's why I'm calling inline position. It's the position in the line. Hopefully that all made sense, and kind of explaining my logic was beneficial. Yeah. Okay, so what I want to do now is I don't even know where everything is. That populates the timeline. Okay, so here's some classes. Yeah, okay, so that's working off of this function. Where do I call this function? Process timeline, right here. This is probably doing stuff. So timeline. Okay, that's the paint function that draws stuff. Okay, so what I want to do is figure out how I'm... Okay, so that makes that. That's for controls. Is set information... Okay, set information is the thing that does the stuff. Okay, so this is good. Get timeline widths right here. Okay, so I want to go... I need to comment some of this stuff, and I should have done this last time, but I was too caught up in solving my problems to solve my problems. So this right here is called externally to set up the information for this timeline overview display control. The timeline we are displaying... Okay, so this is an interesting question, actually, because theoretically, I could pass this a timeline and not make it single branch. So I could add one more thing, but whether or not to display just the timeline or the timeline and all of its children. True for former, false for latter. Okay, so we could theoretically add an additional command. So that way, like, if we have multiple, and I think I'll probably look into adding this actually. But if we have multiple timelines, or like multiple split timelines, we could go into a timeline and see it and all of its children, but not its parent and other sibling timelines and stuff. So that might be something that I want to add, because right now I just have the this timeline, which doesn't have any children timelines being displayed. It's single branch, or I have all, which has everything, right? But I can do something that's kind of in between those two. So I might want to set that up as well, but that shouldn't be hard to do. Should I go ahead and do that now? I should go ahead and do that now while I'm thinking about it, just that way I'm not forgetting. Okay, so timeline overview. I want to make a this and children. So this right here, I can give shortcut keys to. I'm going to make this Control Alt T. Boom. Set. Now if I go over here, this and children. This needs to get moved inside here. And then this is going to take a line kind of like this. Actually, kind of like this. Okay, but this right here, where it says true for single line, I'm going to say false. And then I want to make this timeline plus children. Okay. So that should be fairly straightforward. I can close that. That might be having some random problem. I don't know. It's probably, yeah, okay. That's not surprising. So, nope, not that. I need the error in right here, this one. Right. Remember, this causes problems because I need global in front because I did a terrible dumb thing. Okay, so hopefully that'll fix that other thing over there. But that should add, once I get this compiling again, that should kind of add stuff there. Okay. Now, where was I? I was, yeah, that moved things over. Okay. So right here, record the timeline being displayed for future purposes. Okay. Okay, so the first thing that I want to do is create graphics for rendering process timeline to turn it into event nodes. And then if there are no events in the timeline, we can do some more processing. Okay, so that does that. Let's see. Calculate a pixels per time ppt to scale the timeline to fit on the window. If the last event isn't at time 0. Okay, and then we want to position the timeline's starting location from the left of the screen. Okay, so I just wanted to go through and comment the ever-living snot out of this. That way I could go through here and more easily figure out what the logic is. So that's what the comments are. Hopefully they're self-explanatory. And I know a lot of this is like reorienting myself with what's going on. So this right here is clean up the graphics used. Actually, this is not create graphics rendering. This is create graphics for calculating string sizes. That's what that's actually for. Clean up the graphics used for screen size or for text calculations and render the timeline. Okay, so that's what this is all doing. This right here needs to be replaced. Instead of get timeline width, I want to take everything associated with get timeline width, okay, which is going to be, let's see, so process timeline I use, and that's going to be used right up here. So I want to comment this guy, evaluates a timeline to turn it into timeline event nodes. It's a sort of tree. Okay, the timeline to evaluate the root timeline node to attach this timeline to. Let's see. whether or not to recurse used for single branching or not. A graphics object to use for calculating string sizes. Okay, there we go. That's important information. I'm not necessarily going to go through this and comment it too much, because I know that it works and I don't feel like doing it, but I wanted to create a differentiation with all of this stuff that I was trying to do to calculate a ton of stuff. I'm not sure what this is. Calculate offsets. Where is this called? Find all references. 0 references. Okay. So I'm going to say that everything from here down to here, I'm just going to green code that. I'm going to put a region around it. So a green code is what I call it when you comment out a bunch of code because you're not using it anymore, by the way. It's not, as far as I know, a technical like standard term or anything, but it's just what I call it. So this is going to be an old attempt to find widths of timelines to get the offsets correct. Okay. So I'm getting rid of that. And I'm going to go ahead and delete that out because I'm not going to use that anymore. So what I want to do is I want to make a new attempt. And what this is going to be is this needs to go through the timeline. So actually, let's go ahead and call this, I don't know, void rightmost node processor. Okay, so I can go ahead and just call rightmost node processor right here and not worry about what this is doing anymore. So what I need to do right here is I'm going to actually kind of pseudocode out some of my steps. So this process is going to have me figuring out how am I going to kind of algorithmically build this. Hashtag drink water. So the first step is, let's see. So there's a couple of ways that I can kind of approach this. Because I can go from the root, and if I go down from the root, what I'm looking for is, I don't know. Does it make sense? Does it really matter? I don't know if it matters. Okay, so I think what makes the most sense is to iterate down a timeline, finding all of the event nodes with children, and then locating their rightmost nodes. Okay, so the way that this is going to work is I'm going to make a function. That's the overall order of this. So what I'm going to do is I'm going to make a function. I'm going to call it rightmost node timeline recurse, and this is going to take a timeline event node split node. Okay, so this one should have children. And what this is going to do is, let's see, actually, how do I want to structure this? Because this is basically going to be past root. It's going to go through, and, okay, so what it's going to do is it's going to go through and find all of its children, all basically, so, like, this is going to go while split node is not equal null, if and this is, I'm going to go like this, rightmost node, blah, blah, blah. Event root? No, what did I call it? Events root. So I pass it at events root, so it'll go through the events root and it's going to process it. So while split node does not equal null, stuff split node equals split node dot next. Okay, so the plan here is I'm going to want to figure out what nodes under this one affect it. So I'm going to make another function right here, and I'm going to call it void find rightmost node, and timeline event node I don't know, I'll just call it split node again. So what this is going to do is if split node dot child does not equal null. Okay, so let's see. So there's one caveat with the way that I'm doing this. Which is that I need to check previous nodes that are timeline. So I need to, I'll bake that into here. I'm going to go ahead and bake that into here. And I'm going to actually just call this timeline parent. So if split node, so this node has a child, then I need to find a rightmost node, split node. Okay, so that's the node that I need to do. Then I can just go through and this will just process everything. So this is fairly simple. So this is the function that's going to be the workhorse function for the most part. So this one's just going to like go through all of these, and then that's going to find the rightmost node. And then I also need to rightmost node timeline recurse split node dot child. Okay, so I'm going to need to find this thing's rightmost node, and then I'm going to need to iterate over its children. So I might as well just comment that. Iterate over this timeline's nodes. If this node has a child, then we need to find its rightmost node and process its children for more timelines. Iterates to the next node. Okay, so this right here, and today's probably going to be a little bit of a longish episode, just because I'd kind of like to actually make some sort of progress today. There's some other odds and ends that I kind of want to clean up as well, though, so I need to think for a moment on whether or not to kind of split stuff up. I don't know. You'll have to let me know what you think on that sort of stuff. Obviously, it can't affect this particular project, but it could inform things in the future. But I at least kind of want to finish the logic, I think. And then next time, I can come back in here and check if the logic is working. So it'll be a cliffhanger, right, to entice you to come in next week. So I think I might end this one on a little bit of cliffhanger because there's some other stuff that I need to clean up as odds and ends as well that I remembered later as well. So what I'm going to go ahead and do is right now our job is we need a timeline event node searcher. So searcher is going to be timeline parent. And then what I want to do is check for timelines in the past. So what this is going to be is I want to check my previous timelines. So if while searcher dot previous is not equal null, and searcher dot previous dot win dot raw value is equal to timeline parent dot win dot raw value. So what I'm saying with this basically is if this finds something, then I will be done when I find that thing's rightmost node. Does that make sense? So what I'm going to want to do is so I'm going back because this is going to push me forward potentially. And this is going to be pushed forward by, so anything that occurs before me at the same time as I am is going to be pushed forward the same amount, or is going to need to be pushed forward more than I am. So if this finds something, then we'll use that. So if searcher.child does not equal null, find the rightmost child among these children, because this is the node that's going to most affect us, right? So what I'm looking for in the rightmost child is a child that's going to push us to the right. So if we find one, then I need to move, as it were. And then if I don't find a rightmost child going backwards, then go down. Okay, so remember, this is the node that has the child timeline coming off. So searcher right now needs to equal timeline parent again. And I'll figure out what this algorithm needs to look like. Fairly similarly timed to, or they're probably going to use another function, is my guess. And then this needs to be searcher.previous. Obviously, we can't keep going through here. Yeah, under certain circumstances. So it's going to be a little annoying to make all of the tests for this, but so while searcher does not equal null, searcher equals searcher.next. So I'm just going to go ahead and preemptively put in the iteration loop. I'm not 100% certain if this works or not. I'll think through it a little bit in between episodes. Okay, so what I want right here is okay, I'm going to make a new one called candidate. So candidate is going to be the node that I'm looking at. Right, so I need to check all of my possibilities, as it were, until I've found the candidate that's kind of the furthest to the right, as it were. So there's a couple of things that I need to kind of process for it. Actually, just looking at the time, this is kind of going long enough, and I want to spend a little bit of time between episodes just kind of thinking through my algorithm a little bit. So I think I'm actually going to go ahead and call it here. Sorry, guys, that I didn't quite finish all of this, but it's important, I think, that I kind of think through this and think through the logic of how I'm going to do this, and then I can go over it once I've kind of figured it out. So I think this is the path that I'm going to take, though, because it makes a lot more sense to go through it this way. So I hope that this has been informative and interesting. Until next time, take care, everyone. Bye-bye.